This is a cougar burger. So.
Then why did you start those?
All right. It happens sometimes. All right. Systolic blood pressure is the amount of pressure that the blood exerts on blood vessels while the heart is beating.
Is that what we normally are testing? Blood doping.
So there's two numbers in blood pressure. There's the systolic and there's the diastolic. The diastolic is the resting blood pressure, how much pressure there is in the vein between beats. The systolic is how much there is on the beat of the heart.
You know so much.
Been alive a long time and I paid attention for parts of it.
They made me stand up.
So much
When
going
they did the
on.
blood test, or they did like a test like that to see the pressure. I don't even know if this is the same thing. I just thought of it, so I thought I'd say it. Anyway,
All right.
yeah.
Was it
So-
diastolic or systolic?
I don't know, but I stood up and I almost
Cystic
passed out. The lady was like,
Cystic fibrosis? What? Moving right along, the mean systolic blood pressure for people in the United States is reported to be 122 millimeters of mercury with a standard deviation of 15 millimeters of mercury. The wellness department of a large corporation is investigating whether the mean systolic blood pressure of its employees is greater than the reported national mean.
Do companies
Why?
actually do stuff like this?
I have no idea.
Depends on how much money you have.
It's almost always about money, that's true.
Oh, okay.
A random sample of 100 employees will be selected. The systolic blood pressure of each employee in the sample will be measured, and the sample mean will be calculated. Let mu represent the mean systolic blood pressure of all employees at the corporation. By the way, when you're doing hypothesis testing, your hypothesis is always about the population. It's not about the sample. It's always about the population.
Like everybody?
Right.
The population.
The population is everybody. The sample is not everybody.
I was making sure.
Yeah. No, you're exactly right. All right. Describe a type 2 error in the context of the hypothesis test. So, what is a type 2 error just in general?
When the null is wrong.
So don't worry about whether the null is right or wrong to start with. Just start with, are you rejecting the null or are you not rejecting the null?
When you're not rejecting the null,
All right, so you fail to reject the null.
but it's wrong.
When you should have been rejected.
So, fail to, and this isn't in context at all, so I'm not writing it as part of the answer. So you fail to reject the null. When what?
When it's right.
Should you reject the null when it's correct?
Wait,
No.
when it's not right.
Which means that the alternative is true.
It is right. Yes.
So when the alternative is true.
Like the alternative of the null?
Yes, there's the null hypothesis and the alternative hypothesis. So, in this means the test had a P level that caused us to fail to reject the null. So what is the null in this case?
122.
Where what's 122? Again, in the context of the problem. What's mu?
The mean.
The mean of
Systolic
what?
blood pressure of all employees
Systolic
of the
blood
corporation.
pressure.
Consider the following hypothesis.
Yeah, that the mean systolic blood pressure of all employees at the corporation. It's that whole phrase. Just write it down. Just copy it word for word.
Systolic is on beat or off beat?
Systolic is on beat.
Flaw.
is 122 milligrams of mercury, when, in fact,
Really?
it is greater than 102 milligrams of mercury. Yes. I think I may have. Did I pull that up? All right, so here's what the nice folks at the College Board said. A type 2 error occurs when the alternative hypothesis is true, but the null hypothesis is not rejected. That's a general sentence. It wouldn't get you anything. Okay? In this situation, a type 2 error would happen if the mean systolic blood pressure of the population of employees is greater than 122 milligrams of mercury, but the null hypothesis that it is 122 milligrams of mercury is not rejected. That's what we said. We just said it in the opposite order. Okay? Everybody good with that one? Okay, let's move on to number 2. That's only part of that question, but that was the only part that we knew how to do at this point. Here's one where we know how to do all of it. So this was question number 5 on 2012. So a recent report stated that 35% of the adult residents in a certain city will be able to pass a physical fitness test. Consequently, the city's recreation department is trying to convince the city council to fund more physical fitness programs. The council is facing budget constraints and is skeptical of the report. The council will fund more physical fitness programs only if the recreation department can provide convincing evidence that the report is true. So, the recreation department plans to collect data from a sample of 185 adult residents of the city. A test of significance will be conducted at the level of significance alpha equals 0.05 for the following hypotheses. That H sub 0 or H naught is P is equal to 0.35. That's the skeptical part. We think, it's 35. What we want to test is, well, is it really less than 35? So that's our alternative hypothesis. And notice they have to define P. When you're doing your own hypothesis test, and if it's for proportion, you must define what P stands for. I think we're going to do one like that in a minute where we have to do everything. So, where P is the proportion of adult residents in the city who are able to pass the physical fitness test. Okay. So part A, describe a type 2 error would be in the context of this study and describe a consequence of making this type of error. So, we fail to reject the null even though the alternative is true. Okay? So, less than 35% of the residents of the city can pass a physical fitness test but we fail to reject the null that the percentage is 35%. That's a type 2 error. So again, this is, like I said, this is right off an AP exam. That's the kind of thing they expect you to be able to do when we're talking about type 1 and type 2 errors.
describe the consequence of making the error.
Okay, so if that happens,
They don't build the park or the fitness center.
are they building a fitness center? What are they doing?
They're building.
They're funding fitness programs.
Okay, they don't fund the fitness programs.
So the fitness programs will not be funded, even though
People need them.
it's probably needed.
The city's back.
So, and it's important that you do exactly what they're talking about. So the city will not fund more physical fitness programs. Even though they probably need to. Maybe we should say that a different way.
Well, I do write that down, so. I said even though they probably need them.
No, it would be in the best interest for the people.
Even though not enough people like pass the test.
How about even though, I don't know. I'll just leave it as need to. We'll read the gold star answer in just a moment. So that's part A. Any questions about that? Again, very much like the last one. But then they go on. In part B, the Recreation Department recruits 185 adult residents who volunteer to take the physical fitness test. The test is passed by 77 of the 185 volunteers, resulting in a p-value of 0.97 for the hypothesis stated above. If it was reasonable to conduct a test of significance for the hypothesis stated above using the data collected from 185 volunteers, what would the p-value of 0.97 lead you to conclude? Well, 0.97 is way bigger than 0.05, right?
Mm-hmm.
So,
Are they supposed to be like close to each other? Like how close? Exactly?
we don't care about close.
It has to be exactly 0.05.
No.
Has to be.
What is your favorite phrase?
If the P is low, reject the null.
So you're going to reject the null if it's less than 0.05.
Okay.
And you're going to fail to reject if it's greater than, and we don't care how much greater than.
Okay, that's what I was confused. Continue.
So that's way bigger. So we would fail to reject the null.
Oh, I was just.
And it's not just what would you do, what would you conclude? There is insufficient evidence to conclude that less than 35% of the city's residents can a physical fitness test. When you're writing your conclusion about a hypothesis test, it's always about the alternative hypothesis. Do we find evidence to change our mind to the alternative, or we find there's not enough evidence to change our mind to the alternative?
When is there enough evidence?
If this was less than 0.05, then we would say, oh, we do have evidence we're going to reject the null, and we believe that the alternative, therefore, is correct.
Okay, I had the answer backwards.
Okay? All right. And when I was reading this, I was already asking myself the question in part C. What's the primary flaw in the study described in part B, and explain why it is a concern?
Volunteers.
Yes, exactly right. This is not a random sample, it's a voluntary sample. In this particular case, why is that a concern?
Why would you volunteer to try to pass a fitness test if you didn't think you could?
Right. So, what's likely to be true about the volunteers?
It's fit. They probably think that they're fit.
They're probably more physically fit than the average citizen.
So there's probably less. There's probably way less than 35. Right?
We don't know. We have no way of knowing because we didn't get a random sample. The volunteers are likely to be more physically fit as a group than the city at large. Something along those lines. Let's real quickly look at the. Oh, sorry. Were you still writing?
Oh, no, sir.
Both of you spoke at once, so I heard neither.
No, I have one.
You got it? Okay. All right. So here are the answers to these. In the context of the study, a type 2 error means failing to reject the null hypothesis that 35% of the residents in the city are able to pass the test, when in reality less than 35% are able to pass the test. The consequence of this error is that the council would not fund the program, and the city would continue to have a smaller proportion of physically fit residents than the council would like. That's a better answer than what I wrote.
Yeah.
Because the p-value of 0.97 is larger than alpha equals 0.05, we fail to reject the null hypothesis. There is not convincing evidence that the proportion of adult residents in the city who are able to pass the physical fitness test is less than 0.35. You don't need to write this part. That last sentence, I looked at the grading, it's like, yeah, that's nice to say, but you don't need it. And then the last part, this is not a randomly selected sample because the sample was selected by recruiting volunteers. It seems reasonable to think that volunteers would be more physically fit than the population of the city adults as a whole. Therefore, the sample proportion will likely overestimate the population proportion of adult residents in the city who are able to pass the physical fitness test. Basically what we said. All right, let's go on to number 3. And I don't think I found the answer for this yet. This is from 2009, number 5. For many years, the medically accepted practice of giving aid to a person experiencing a heart attack was to have the person who placed the emergency call administer chest compression plus standard mouth-to-mouth resuscitation to the heart attack patient until the emergency response team arrived. However, some researchers believed that chest compressions alone would be a more effective approach. Actually, I remember going through all this with CPR training, where it's like, do you have to, do you not? And it changed one way and then it changed the other. And because it's changed twice, I don't remember what the right thing to do anymore is.
They change first aid stuff all the time.
When did you go to CPR training?
I've been multiple times, just as a teacher every now and then. They want someone trained in CPR in each one of the buildings, supposedly. Although the training we had here was pretty sketch.
better than
That's
no
right.
training.
Really?
All right. So in the 1990s, and this honestly,
Sounds like an awful study.
Yeah.
it kind of does. And I'm like, is this really? I mean, it's a real study apparently,
Rats.
but it almost feels. What's
Rats who had heart attack.
1 and 2 and 1 and 2 and 1 and 2. And we give a rat mouth to mouth. And how are you going to have him have a heart attack?
You zap them.
That's so
Yeah, like,
mean.
that's unethical.
I think that's
Bruh,
different.
they did experimenting on people who were like having heart attacks.
All right, so in the 1990s, a study was conducted in Seattle in which 518 cases were randomly assigned to treatments.
Like, how did they give them heart attacks?
They didn't. They had
Like the
people
911
responding to emergency calls,
Oh, and they're like dying.
and they would say, "All right, on this one, we want you to do this. Let me know what happens. Thanks."
That's let me know what happened.
Give you a call back.
Yeah.
They died. What? Yes, I was thinking.
So a total of 64 patients survived the heart attack.
Oh my gosh, that's a lot of people that died.
Yeah,
Yeah.
people die of heart attacks at a pretty high rate.
What? My dad was with his friend when he had a heart attack one time. He was driving to the emergency room.
He had a heart attack while he was driving,
No.
or he had a heart attack and
My
then
dad was with his friend, and they were like eating in a restaurant.
right.
Eating kind of like grill.
Oh, I love that place.
And his friend had a heart attack, and my dad had to take him to the hospital.
Wow.
He's still alive though. Yeah.
Okay. Yay.
Yeah.
I guess he didn't get the placebo then.
They had a placebo for this?
No, I'm just teasing.
Do nothing.
That's horrible.
Yeah, do nothing and see what happens to
Let the
those.
guy sit there.
All right.
See if they're faking it.
So 29 were in the group receiving chest compressions plus standard mouth-to-mouth resuscitation, and 35 in the group receiving chest compressions alone. The test of significance was conducted on the following hypotheses. So H0, the survival rates for the two treatments were equal.
That's so grim.
And the alternative, the treatment that uses chest compressions alone produces a higher survival rate. So this test resulted in a p-value of 0.0761. So they're not making you do all the math for this. They're just telling you stuff. All right. Interpret what this p-value measures in the context of the study. All right. So if the null hypothesis is true, so the survival rates for the two treatments are equal, then the probability of getting, now which one is the one we're interested in? Well, it's the chest compressions alone. And how many of them survived in the chest compressions alone?
35.
So a p hat of 35 out of how many?
240.
240? Or better or higher is 7.61%. The or higher or lower, depending on which it is important. It's not that they just get that, it's they get that or whichever tail you're looking at. And since we want a higher survival rate, this or higher. All right, part B.
How did you know that was the one that it was talking about?
Because we're interested in what our alternative talks about chest compressions alone. So we want to see, is chest compressions alone better? All right, part B, based on this p-value and the study design, what conclusion should be drawn in the context of this study? Again, use a significance level of alpha equals 0.05. Okay, so our p-value is equal to 0.0761, which is greater than 0.05, which is our alpha. So what are we going to do?
Fail to reject.
So we fail to reject the null. And again, failing to reject the null is a general statement. So now our conclusion needs to be about the alternative. Do we believe that the treatment that uses chest compressions alone produces a higher survival rate?
No.
No. We have insufficient evidence to conclude that CC chest compression alone produces a higher survival rate. So, part C, based on your conclusion in part B, which type of error, type 1 or type 2, could have been made? So we failed to reject the null.
It's a type of 2 error.
So it's a possible type 2 error. What's one potential consequence of this error?
You don't only do chest compressions. Wait, hold on.
If you have a type 2 error, you failed to reject the null, so you didn't choose the alternative hypothesis when it's really true.
So then you're not just giving people chest compressions and that saves more lives.
Correct. We would decide not to just give chest compressions to heart attack victims when it would save more lives. Got it? Let's see if we can get at least part way through the last one. I think it says just do one part.
Sure does.
Just do part B.
Just do part B. All right, so let's look at the last one. This is from 2008B. So, a researcher wants to conduct a study to test whether listening to soothing music for 20 minutes helps to reduce diastolic blood pressure in patients with high blood pressure compared to simply sitting quietly in a noise-free environment for 20 minutes. 100 patients with high blood pressure at a large medical clinic.
Students, please pardon this interruption.
I don't think I will.
Students, we really enjoyed seeing you pack your kindness and our anything but a backpack day. Your creativity's been awesome. We also really enjoyed seeing the encouraging notes and help you've given your peers, and I hope you enjoyed the Rice Krispie treats from our PTO today. Remember that tomorrow is Take Care of Others as you dress like your favorite soccer mom or grill dad. So make sure that you're coming up with ways to dress like a soccer mom or grill dad tomorrow. It's also our day to be kind to underclassmen. So seniors, think about maybe buying lunch for underclassmen and other high schoolers.
I'm buying someone lunch. They pay me.
Middle schoolers, maybe think about, maybe being able to read to elementary kids or doing something nice to them. So that's our Be Kind to Underclassmen Day is tomorrow. I want to point out our winners and caught for being kind today. If you want to go by Miss McCatherine's room to get your prize, but we have a few winners. Carrington James for
Did you win yesterday too?
lending her charger to another student. Miss Freeman for taking the time to explain instructions again and again. Libby Frank for helping a new student around campus. To Tyler Blossom for always showing kindness to his classmates. For Giselle Gonzalez for picking up trash at lunch. For Alara McNeil for bringing cookies for people. And just remember, we are looking for you to be getting caught being kind. So as you're a soccer mom or girl dad tomorrow, look for ways to be kind to others. Thank you.
You're welcome.
Okay, so the null hypothesis for this study is that there is no difference in the mean reduction of diastolic blood pressure for the two treatments. And the alternative hypothesis is that the mean reduction in diastolic blood pressure is greater for music treatment. If the null hypothesis is rejected, the clinic will offer this music therapy as a free service to their patients with high blood pressure. Describe type 1 and type 2 errors and the consequences of each in the context of this study and discuss which one you think is more serious.
Is this a real question that we can have?
It's a real question.
Sounds awful.
No, I like this question.
Okay, so what is a type 1 error in the context here? Pardon?
The null is no.
When you fail to reject the null, wait, no.
Oh, type 1 is you reject the null.
You reject the null, but you're supposed
Should
to
have
not.
failed.
But
You failed, and then you're supposed to.
You're supposed to accept the alternative because you can't accept the null.
Right, so you rejected the null and accepted the alternative hypothesis when the alternative is not actually true. So in this case, and I'm not going to have time to write all this down, but we'll just follow it together. So here, we rejected the null and decided that there is a mean reduction in diastolic blood pressure is greater for the music treatment.
So if you make a type 1 error, you give treatment.
In this case, yes.
It doesn't actually make it better.
It doesn't actually make it better, so that's a problem.
Yeah.
And from the medical clinic side, they spent money giving this treatment.
Yeah.
That's a problem when it doesn't actually help. Type 2 error, we failed to reject the null, even though the alternative is true.
So then you're not giving treatment, but it does make it better.
We're not giving any treatment, but it could help the people. Which one is more serious?
I think the
The
first
second
one.
one.
Yeah, I think they will accept either if you make a case for
To
it.
be fair, they didn't have to volunteer it for free.
Yeah, I would say probably, let's see, in the first one, what did you do?
The first one, you lose. They don't feel better. Like, they don't actually feel better, but you're wasting money. In the second one, they don't get treatment, but it could help them.
See, I'd say the second one is more serious because it could actually help them. The first one, it's like, yeah, you've wasted some money, but has it hurt anything? No,
Yes. All sugar.
just your bottom line. All right.